Hello and good morning to all of you. I am Sahil and I am present a presentation on correlation. So in correlation we are talking about correlation and covariance functions. Second is ergodic process, and third is Gaussian process, and fourth is properties of autocorrelation and cross correlation functions. So first of all we are talking about correlation. What is correlation? Correlation is a similarity of coherence between two signals, or on the other hand we can say that it is the measure of degree to which that two signals are similar. Correlation are of two types: autocorrelation, cross correlation. First of all we are talking about autocorrelation. Autocorrelation gives a correlation of a function with its shift version. It is also known as serial correlation. It is similarity between observation as a function of the time lag between them. Of autocorrelation, so given below. So it is the mathematical process. Let xt be an energy signal. Its autocorrelation function ACF Rxt is equal to integration of minus infinity to plus infinity xt x t minus tau dt is equal to minus integration of minus infinity to plus infinity x t plus tau x t dt. When function is energy signal, then R x t is equal to limit t to minus t to infinity 1 upon t integration of minus t upon 2 plus t upon 2 x t minus tau dt. Here tau is the shift or log parameter. So it is a cross correlation. It is a measure of similarity of two series as a function of the displacement of an relative to the other. It is also known as slide dot product or sliding inner product. The cross correlation is similar in nature to the convolution of two functions. It is a mathematical process of cross correlation. R f j tau is equal to integration of minus infinity to plus infinity f t g t minus tau x dt. So if two signals having some nature of various having a minimum shift, that is two signals lying at same time, thus maximum overlap. So cross correlation is maximum. So this is the properties of cross correlation. There are 5 properties of cross correlation. And next is the Gaussian process. It is a process of collection of random variables indexed by time or space, such that even finite collection of those random variables has a multivariate normal distribution. The distribution of Gaussian process is the joint distribution of all those random variables, and as such it is a distribution over function with a continuous over functions with a continuous domain. So this is ergodic process. It is also called stochastic process. It is said to be ergodic if its statistical properties can be deduced from a signal sufficiently long random signal of random sample of the process. A random process is said to be ergodic if the time averages of the process tend to the appropriate sample average. This definition implies that with probability 1 any sample average of x respect to t can be determined from a single sample function of x t. Clearly, for a process to be ergodic, it has to necessarily be stationary, but not all stationary processes are ergodic. So thank you and have a nice day.